Okay, so what I want to do is I want to kind of go through some of the demonstrations that for dry ice that we're going to look at do sublimation. Now, remember the main component or difference between dry ice and solid ice or regular water ice is what they're made out of. Water ice is made out of H2O or frozen water. Dry ice is made out of frozen carbon dioxide. It takes a much lower temperature to freeze carbon dioxide. I believe it's negative 70 or 80 degrees Celsius, whereas water freezes at 0 degrees Celsius. Now, a couple things about dry ice. You can buy it in a store. You should never touch it with just bare hands because, it is so cold that it will cause frostbite pretty rapidly if you're not careful. So what I'm going to do is I'm just going to go ahead and get myself a chunk of it. Again, you never want to touch this with your bare hands because it is really cold, like negative 30. So if you look at dry ice, first of all, you can tell is the look of it is different. It's a little more white. It's not clear like regular water ice is. Now, I'm going to go ahead and drop this in the water. Now, again, dry ice does an interesting thing where it is, well, it spills all over my table, first of all. It changes directly from a gas to from a solid to a gas. So what's happening here, besides the fact that I'm spilling all over the place, is it's not boiling. If you can see inside the beaker, the gas coming off of the carbon dioxide is not boiling. Well, I guess it's sublimating. So it's changing directly from that dry ice, right from that solid carbon dioxide, and it's breaking right away to a gas. The foam coming off it is what you're seeing is it's just water vapor being trapped in the dry ice gas. Now, place this in a kind of precarious position. Actually, I'm gonna pour some of this water out. Apologize for this. All right, that's better. All right, so a couple things we want to notice about this. First of all, as I hold this up, what I want you to do is notice about what happens to the smoke as it comes over the top. See, it leaves the top, but then it kind of falls. It doesn't keep rising up. The reason is carbon dioxide is more dense than the air around it. The air around it is just nitrogen, oxygen, carbon dioxide, a little bit of carbon dioxide. This is pure carbon dioxide. It's a little more dense than the air around it, so it will sink in this air. Now, because it will sink, I can actually pour it. And what I want you to notice is, this could be the next part of the lesson. Try not to fill it with water. All right, so again, because the carbon dioxide is more dense than the water, I'm going to let this sit in the corner here. You see how it kind of fills the bottom of the aquarium first. We'll let that fill up a little bit. Oops. Now, in here I have a candle. Now again, what's necessary for a candle or any oxygen or any burning is oxygen. So what's happening as the carbon dioxide builds up or the concentration increases, the candle goes out. Well, why does the candle go out? Well, because it needs oxygen. And the gas on the bottom of this is carbon dioxide. It's much more dense than the air around it. So as it fills up, it pushes that other air up and out of the tank. You can actually see a level of it. Now, I'm going to let that build up a little bit more, and we'll see how that density can make a difference. And again, this is just sublimation. It's just changing from a solid right to a gas without that liquid phase. I don't know if I have enough gas in there or not, but I can try. So I want you to look carefully at this. See if I can pull this off. Almost. There we go. We got one. See how this bubble is floating? Well, I'll do another one. See how these bubbles are floating in the gas? That's because that gas is so much more dense than the air around it. So these bubbles don't sink all the way down to the bottom. They're floating on this more dense gas because what are they made of? They're made of air. Now, again, they're bubbles. So the bubble is just that water in the soap holding on together in that property called surface tension. Okay? So that is that one. This is why we use it for fire extinguishers, because if I'm using carbon dioxide gas, first of all, well, it's really cold, but when I use it as a fire extinguisher, it's just smothering out the oxygen. I'm not using water, which is good because if it's an electrical fire and I use water, basically I'm going to spread that fire and make it much worse. If it is a chemical fire, I can spread it. But with carbon dioxide, all I'm going to do is kind of take the oxygen out. I'm going to let this tank kind of continue to fill. Then I'm going to do the bubble volcano real quick so you can see that. And again, dry ice is pretty much available any grocery store. I got mine at Jewel. It's not that expensive. It's nice because when people use it for camping, you can buy us a fill cooler with this. First of all, it's not going to last as long. It's going to go. It's going to warm up as the temperature warm up. It's going to change the sublimate much quicker than regular ice would. However, when it's done, I want to have that water residue, which is kind of a pain. All right, let's take a piece, break it up. So I want this to react. So I have one big chunk. But again, if I want to increase the reaction rate, one thing I can do is increase my surface area. All right, so let's see if we can pull this off here. All right, so what we have here is just water. The water, again, it's warmer than the dry ice, so it's going to cause it to sublimate pretty quick. If I can pull this off, it's sometimes tricky. I can make my bubble volcano. Sometimes it's hard to do. All right, wish me luck. See, as soap gets in it, it becomes a problem. I think I used a towel. Give me a second. If not, I will come back and I'll do this again. There we go. Some of it? No, it's got too soapy. All right, so I'm going to try this with a different towel in a minute. I'm going to pause this and come back to this. Okay, as I turn around, what I wanted to happen actually happens. So what I have is this big balloon of soap, the surface tension holding it together, but when it erupts, again, each time I erupt this, that's just water vapor. So let me try this one more time. Let me clear this out. Try to clip that part out of this. I'm going to try hot water this time because the hot water will cause the reaction to occur a little quicker. Remember, hot water means the molecules are moving faster. They're moving faster, they're colliding more often. Another interesting thing about dry ice. Let me find my glove. Is when it reacts to metal. So here I have a spoon. You can't really hear it, but you can kind of see if I listen carefully. What that is as it hits the warm spoon, it changes to a gas, and that gas needs somewhere to go. And so as it's pressed against the side of the spoon, that gas squeaking through the openings is what's causing that sound. There's my other glove. All right. All right. Let's try this one more time. Try with a different washcloth. All right, and I apologize for that. So again, let's see if we can pull this off. Yeah, come on, come on, come on, come on, come on. Oh yeah, that's got it. All right, so this is the bubble volcano. If you look closely, I have just one bubble on the top. As the carbon dioxide builds up and builds up, it expands, but that bubble's got surface tension. That bubble can hold it together because of the attraction between those molecules. Pay attention, I'll try to come up the table. When it erupts, it's going to reaction. And watch the gas as it erupts, because it's going to fall. Because why? That carbon dioxide is more dense than the air around it. You can see the beaker. It's kind of hard to see. This is still reacting because until all that carbon dioxide has changed to gas, it's going to continue to sublimate. Oh, it's getting close. Mr. Rainey, you want me to wobble? I don't want to break it. Not going to break it. That is a good bubble volcano. It's also called the bubble crystal ball because if you look at all the colors on the bubble, you can see the smoke inside of it. It's almost like a crystal ball. It's pretty cool. The video that I attached to this presentation will be much more clear, but mine's cooler. Why? Because I did it. You can actually see the smoke like puffy. It's like almost a crystal ball. This is probably one of the best ones I've ever had in terms of a bubble. That is fantastic. And all that, again, that's just surface tension of that bubble, those water molecules holding together. That attraction we talked about on Wednesday, or when we talked about surface tension. That's all that's holding that gas in. But as soon as it gets too much, the gas will cause the bubble to pop. And again, all that gas, it won't go up in the air because it's more dense than the air. It's going to go ahead and just float over the table and cascade down the side. Good word, cascade. Oh, Mr. Rainey's playing with fire. Playing with fire. I will honestly say, in my many years of doing, there we go. That was probably one of the better reactions I've ever had. All right, so those are dry ice demonstrations. I'll attach some links for some other demonstrations along the way, that in case you want to see. Again, you can get